Alright guys, so we're going to do a video today about scientific notation. And a lot of you probably don't know what scientific notation is because usually a lot of times you only see it in science. And that's because scientific notation is a way to write very, very large numbers and very, very tiny numbers. So big or so small you probably wouldn't even see it in regular life. So scientists, if you're working as doing some science work and you're doing some data analysis, you could see numbers as big as 13 billion, I'm pretty sure this is. But with scientific notation, we can write that more efficiently. We can write 13 billion like this as 1.3 times 10 to the 10th power. So I'm going to teach you guys how to do this and how to read it. So in order to do scientific notation, you should understand the order of operations. And we're not going to go too far in depth because we only really need to know two things. But take, for example, this number right here, 1.2 times 10 to the second power. There are two ways to look at this. If I do 1.2 times 10 and then I square it, then I'm essentially getting 144 as my answer. But if I do it this way, if I do 10 squared first and then I multiply by 1.2, then I get 120. Well, which is the correct way to do it? That's where the order of operations comes in. Order of operations here, this is the mnemonic for it. It's parentheses, exponent, multiplication, division, addition, subtraction. And here, obviously we have an exponent here, and this is a multiplication. And since exponent came first, we do the exponent first. So we're gonna do 10 squared is 100 times 1.2, and we get 120. So 120 is actually the correct number here. And that's pretty much all we're going to do with order of operations, because in scientific notation, it will always be the same layout. So basically what I told you is pretty much all you have to know. So yeah, 10 squared first, and then you multiply. So next we're going to do a quick exponent crash course, because I don't know where everyone is in exponents. So we're just going to do a quick thing. I'm going to teach you all you need to know for this subject. And it's not very much. So this is your basic exponent. We have 3 to the 6th power. And basically what that's telling me is 3 is going to be multiplied by itself 6 times. So when I write this out long form, it's going to be 3 times 3 times 3 times 3 times 3 times 3. Notice there are 6 3's total in here. That's because the exponent told me to do it 6 times. So I didn't even bother writing what number this adds up to because it doesn't really matter. So the next one we're going to do is 10 to the 4th power. And what that's telling me, 10 is our base number. It's going to be multiplied by itself 4 times. So I've written that out. We have 10 times 10 times 10 times 10. And that's pretty much all the exponent stuff I'm going to go over. Because for scientific notation, the base will always be 10. So you're always going to see something that looks a lot like this, what I'm circling with the laser pointer right here. This 10 to the 4th. Scientific notation usually varies the exponent. So instead of the 4th power, it might be the 10th power, like we saw before. It could be something tiny, like a -5. But for now, we'll just go off that the base will always be 10 for scientific notation. All right. How do we write in scientific notation? Well, it's more simple than you think. You take a large number. We're going to use 150. It's really not that large, but it's large enough for me to get my point across. So we got 150. What we do is we imagine where the decimal point goes. And really, since this is a big number, decimal point just goes at the very right here. So it's 150 decimal point. If this was like 150.5, then we would actually see the decimal point, and it would be right here. So what do? We move the decimal point so that it is between the first and second number here. So what I mean by that is we see in this number, there are 3 digits. There's a 1, there's a 5, and there's a 0. And what I simply want you guys to do is move this decimal point right over here between the 1 and the 5, first and second number. and we get 1.50. And now we need to know how many numbers did we need to jump to get to 1.50. Well, we had 150 with the decimal point right here, and then we popped it over once, and we did it again. So that we jumped twice. We needed to move 2 spots, and that 2 spots, that 2 is going to tell us our exponent. So in scientific notation, we're going to keep what we did before here with the decimal point between the first and second number, and then we're going to write what we got, the 1.50, and then we're going to multiply it by 10 to whatever power, however many spots that we jumped. So we jumped twice here, so we're going to put it to the second power. So that's our number. 150, written in scientific notation, is 1.5 times 10 to the second power. So what if it's small? At the beginning of the video, I told you that scientific notation is for really big and really small numbers. So I'm going to teach you how to do really small numbers. So this is a small number. This is 0.0034. So it's very small. Now we're going to do the same thing. But this one we can actually see the decimal. It's right here. It's 0.0034. So we're going to use this decimal. And we're going to do the same thing, except we're going to move it the other way. We're going to move the decimal so that it is between the first and second number. And by number, I mean non-zero. So I'm going to move it between the 3 and the 4 in this case. So I get 3.4. Now, again, we have to figure out how many numbers do we need to jump to get to 3.4. Well, we started here, and then we jumped 1, 2, 3 times. So our exponent is going to be 3. But wait, this is a small number, so our exponent is actually going to be negative. So the real answer is this, 3.4 times 10 to the negative 3. Remember, if your number is small, like this one here, 0.0034, that number is small, the exponent is going to be negative when written in scientific notation. All right, so we have some concept questions here. That's more. So we have 23,456 and 0.000845. Now I want you guys to write it in scientific notation. I'm going to leave a little pause here for you guys to pause the video and do it on your own before I go over it. All right, so now I'm just going to go over it. So we have 23,456. Well, what did we do last time? We first found the decimal point. And again, since it's a big number, it's whole number, there's no decimals. So we just put it right here on the right side, right at the end after the 6. So we move the decimal between the first and second number, just like we did last time. So it's going to be between the 2 and the 3 here, because it's the first numbers. So it's going to be 2.3456. We're going to look how many places do we need to jump to get 2.3456. Well, we're going to do it. We started with the decimal point here after the 6, and we jumped 1, 2, 3, 4 times. So our exponent will be 4. So our number is going to be, and then we ask ourselves, is this a big or a small number? And then we look up here, it's 23,456. So this is a big number. So we know that this exponent here, this 4, is going to be positive. So we take our 2 pieces, one piece being 2.3456, and we have our exponent here, 4, and we put it in the right formation, and it's 2.3456 times 10 to the 4th. Now for our next one, we do the exact same thing. We find our decimal point. It's much clearer on these tiny numbers. It's right here. And then we move the decimal between the first and second number. When I'm looking for non-zero numbers, the first non-zero numbers here, and that's going to be right here, this 8 and the 4. These are the first non-zero numbers to come in this sequence. So I'm going to move the decimal point between the 8 and the 4 because it's the first non-zeros, and we get 8.45. Now, again, I'm repeating myself because we can do this. This is how many we ask ourselves, how many places did we jump? We started with this number 0.0000845, and we ended up with 8.45. So the decimal place ended right here. So we jumped 4 spots. 1, 2, 3, 4. And we gotta ask ourselves, is this a big or a small number? And, well, the number we started with is 0.000845. That sounds pretty small to me. So our exponent is going to be negative. So our exponent is going to be a negative 4. So when we write this, we take our two pieces. We have our 8.45, and we have our negative 4. This will be a negative 4. And we write it 8.45 times 10 to the negative 4th power. And that's all for this slide. We'll move on. And now we're going to do the opposite of what I've been doing. I'm going to take something that's written in scientific notation, and I'm going to write it in standard form. I'm actually going to give you guys a little pause here. So pause right now if you want to do it on your own, which I do recommend, before I go over it. So this is our number here, 3.4 times 10 to the 2nd power. While I'm looking at this, I'm going to go back to our order of operations. We remember that we do 10 squared first. So that's going to be 10 times 10. So that's 100 times 3.4. 100 times 3.4 is 340. And there we go. And we could do it this way also, where we just move the decimal place 2 spots, where so we know the decimal place, we know the exponent is 2, so that means the decimal place has to move 2 spots. And we know that this is a positive 2, so we're going to be making a big number. So if I move it to the left here, I end up with 0.034, which is a small number. But if I move it to the right here, 1, 2, I end up with 340, which is a big number. So we look at this exponent to give us a clue of what it's asking of us. And remember, we're not actually doing anything to these numbers. We're just writing them in a different format. So next one we're going to do is 9.5 times 10 to the negative 3rd. We're going to do the same thing. We're going to take the decimal point. We're going to move it 3 spots since we see a 3 here. And then we're going to ask ourselves, is this a big number or a small number? Well, this is a negative exponent, and remember we said that negative exponents are with small numbers. So if I move it 3 spots to the right here, it becomes like 9,500. That's a big number. If I move it to the left 3 spots, it becomes 0.0095. So it's the small number because there's a negative exponent. So our answer is 0.0095. And again, this is not changing the numbers, we're just writing it in a different format. Because 9.5 times 10 to the negative 3 is the same number as 0.0095. They're just written in a different format. And that's it. That